Hello everyone, my name is Mukesh Kumar and I am pursuing B.Tech in Electronics and Communication Engineering from PKR College of Engineering and Technology. Today I am going to present my internship project titled Electric Vehicle Advanced Driver Assistance Systems or EV ADAS Dashboard, developed using STM32 Bluepill, PICSimLab and Python. This project was completed as part of my Embedded Systems Internship at Emertxe Information Technologies. During this project, I learned embedded programming, UART communication, simulation using PICSimLab, and Python-based real-time dashboard development. Now let's begin with the presentation. Here comes the introduction slide. Before discussing the project, let us understand what EV ADAS means. First of all, EV stands for Electric Vehicle. ADAS stands for Advanced Driver Assistance System. ADAS is a collection of safety features that help the driver avoid accidents and improve driving safety. In modern vehicles, these systems continuously monitor the surroundings using different sensors. Some common ADAS features include collision warning, blind spot detection, lane departure warning, adaptive cruise control, and parking assistance. In this project, we focused on monitoring important vehicle parameters and displaying them on a real-time dashboard. The dashboard receives data from the embedded firmware through UART communication and updates the display continuously. Next slide tells about the problem statement and proposed solution and the flowchart of the system. Mainly, this slide shows the complete workflow of the project. The first stage is the STM32 Bluepill. Here we can see the cut block. The first stage is the STM32 Bluepill microcontroller, which is simulated using PICSimLab. Inside the embedded firmware, different vehicle parameters such as speed, battery, state of charge, torque, motor temperature, ultrasonic sensor distances, alarms, and faults are generated. These values are transmitted through UART communication at a baud rate of 115200. Mainly, we are using the baud rate 115200. The Python dashboard receives the UART dashboard using Python serial library. The received data is parsed and displayed using the Matplotlib library. Finally, the dashboard updates the speedometer, battery percentage, speed, history graph, EV metrics, and per-eye ADAS visualization in real time. This creates a complete simulation of an EV monitoring system. So this slide explains us what we are going to do in this project. Next, the project uses both embedded and software development tools. The hardware platform is a STM32 Bluepill microcontroller simulated using PICSimLab. The firmware was developed using STM32 Cube IDE in Embedded C. Python was used to create the dashboard interface. The PySerial library is used for UART communication. The Matplotlib library is used for creating gauges, graphs, and visual indicators. VSPE software was used to create virtual COM ports for communication between PICSimLab and the Python dashboard. Together, these tools create a complete embedded system simulation environment. Slide 5. This is mainly the features of EV ADAS dashboard in which we are going to implement and what we are expecting the output. So, this project provides several important features. First, it displays vehicle speed using a graphical speedometer. Second, it continuously monitors battery state of charge and estimated driving range. Third, it displays motor torque, accelerator position, brake percentage, and motor temperature. The dashboard also provides collision warning by monitoring the front ultrasonic sensor. Blind spot detection is implemented using the left and right sensors. Alarm levels change automatically depending on detected situation. The dashboard also maintains a speed history graph for continuous monitoring. All these values are updated in real time through UART communication in Python dashboard. And not only explain the PPT, I will also further show the obtained output of the Python dashboard while demonstrating the project. Let's move on to the next slide. This is the working of EV ADAS dashboard. Here you can see that I have pasted the screenshot of the PICSimLab spare parts are shown. Now let us understand each section of the dashboard. On the top left, we have the speedometer. It displays the current vehicle speed and changes dynamically according to the received UART data. At top, we have the battery. This is about the actually that is about this one. At the top center, here we can see the battery battery monitoring section. It shows the battery percentage estimated, driving range and current driving mode. Below the TV metrics panel displays torque, accelerator, brake, motor temperature, alarm, fault signal. At bottom left, the speed history graph continuously plots the vehicle speed over time. On the right side, the bird eye ADAS view shows the vehicle and nearby obstacles. The front obstacle is displayed using ultrasonic sensor distance. Left and right obstacles indicate blind spot detection. Here I have not got because the values I have given are some far to the vehicle. In the demo, I will show you them. The time to collision value is also calculated and displayed. If an obstacle comes to close, the alarm changes from normal to warning and finally critical. This helps for driver understand dangerous situations in real time. Next, the results. The slide shows the final output of the project. After successfully establishing UART communication between PICSimLab and Python, the dashboard starts receiving live data. As vehicle parameters are updated continuously, the speedometer changes according to speed. The battery information updates automatically. The EV metrics display real-time values. The eye view shows nearby obstacles. When the obstacle distance decreases, collision warning and blind spot detection become active. Alarm levels also change automatically according to the safety condition. This demonstration successful communication between the embedded firmware and the dashboard. In this project, I even though faced some challenges and finally I have find the solutions and implemented. Initially, UART communication was not working correctly. The dashboard was unable to receive serial data. I checked the UART configuration and verified the baud rate of 115 to 00. Another challenge was virtual COM port configuration. I solved this by configuring VSPE correctly and matching the COM ports used by PICSimLab and Python applications. Finally, after debugging each issue step by step, I successfully established communication and obtained the desired dashboard output. This project greatly improved my debugging and problem-solving skills. Collision and future scope. To conclude, this project successfully demonstrated an EV ADAS dashboard using STM32 Blueprint, PICSimLab and Python. It provides real-time monitoring of vehicle parameters and important ADAS safety features. The project also helped me understand embedded programming, UART communication simulation, Python programming, and system integration. In the future, this project can be extended using real STM32 hardware instead of simulation. Additional features such as GPS canvas communication, mobile application support can also be added in this project. These improvements can make the project more suitable for real autonomy applications. Here is the actual roadmap of this project. First I have simulated, then I have done in the STM32 Cube IDE, then I have started the UART communication, then using the Python dashboard, I got the dashboard output. And in the future, we can enhancement in real world. Thank you. This concludes my presentation on the EV ADAS dashboard. I would like to thank Emertxe Information Technology and my mentor for providing this valuable learning opportunity. This project helped me gain practical experience in embedded systems, communication protocol, simulation, and Python-based visualization. Thank you all for your valuable time and attention. I would be happy to answer any questions. Actually, I'm sorry for concluding my presentation. Also, I need to live. I need to demo in live. So now I need. Actually, this is my folder. Okay, this is my EV dashboard. First, let us look after the IOC. Okay, this is my IOC. I have configured the pins such like this as my mentor have guided me. These are some UART pins, some GPIO pins, etc., ADC pins. And now let's move on to the main part, main scene. Okay, this is the code of my main C in which I have implemented. Uh, I have like this. I have written my code. Not only in the main C, I have also some header files and some source files. Some header files are like ADAS H, common H, and EV control H, fault H, and some source files like fault C, like EV control C. EV control C is the main controller part of my ADAS system, in which I have implemented most of the part. For example, here, if for example, let us discuss one point. Here I have given EV speed kilometer is equals to 60. If I put this from 100, my car speedometer will start from 100. Actually, I need to keep it from 0, but just for demonstration purpose, I have kept it as 60. And now let's build this project. Okay, we have got the exact output. Now let us go into the PICSimLab. Okay, this is PICSimLab, in which let us again load the code since we have built now. This is my new binary file. I've got the output. Once okay. This is my acceleration pedal, brake pedal, SOS pedal, motor temperatures pedal. And this is my front ultrasonic sensor. This is my left ultrasonic sensor. This is my right ultrasonic sensor, which detects the bird eye. And these are some indications I have given. This is a buzzer or alarm. When it has critical condition, the buzzer will be active. If I change the values, let's increase the motor temperature. Now if I open my terminal, it will tell me, see, the output is coming. So our next part is to design a Python dashboard for getting the in a clear manner. So let us open command prompt. Let us open it as an administrator. Now we need to first change the direction. Select. Now we need to go into our folder. Then even okay. Now we need to keep our Python code. So where is my Python code? It is in this folder. Should it is there in this? Yes. This is my Python code. I need to paste this in the command prompt. Before running it, I have one work. I need to go to VSPE. It is actually connected actually, but I will connect. First, I will disconnect it. I need to the connection process is like this: virtual pair, next, and we need to give our ports, etc. It is already in the connected mode. Once we need to check. Once let us check in our device manager ports. Already it is connected virtual serial port COM5 and COM8. So just we need to give as here it is COM3. We need to give either COM5 or COM8, and we need to change our name as it is EV underscore dashboard, and now we need to enter. And automatically maximum the dashboard will open. Okay, you can see it. Okay. Now we need to go into the and now let us change it. Change some values. We can so we will increase will change. First let us look into the virtual output in this virtual terminal. So here we can see front 66, left to 16, right 66, time for collision blind spot. Now let us check in this. See, as we kept the front one side shown this. See, here we have kept the front bird as 68 and right side as 68, and so some type of the warning is coming because the front vehicle is much closer to our vehicle. So time to collision alarm is critical. Fault is acceleration 76. We can see it, and this is our battery percentage. So we'll take the car into the normal condition now, and we'll check once again. See, it has changed into the normal. Let's apply the brake and check once. The acceleration and we'll apply the brake, we'll increase motor temperature and decrease motor temperature. Okay. Yeah. Okay, this is the actual output of the designed project. Let's go into the PPT. This is the output as we have got the dashboard output as we have discussed before. This is it. Thank you.